Streams and files. Introduction. We will discuss the following topics in this chapter. The complete stream zoo, zip file streams, use of streams, writing delimited output, string tokenizers and delimited text, reading delimited input, random access streams, object streams, understanding the object serialization file format, altering the default serialization mechanism, serializing singletons and type-safe enumerations, versioning, using serialization for cloning, file management, path, reading and writing files, copying, moving and deleting files, creating files and directories, getting file information, iterating over the files in a directory, zip file systems, new input-output and regular expressions. The complete stream zoo. Java has a whole zoo of more than 60 different stream types. The following diagram shows the input and output stream hierarchy. Use subclasses of the abstract classes reader and writer for Unicode text. The basic methods of the reader and writer classes are similar to those for input stream and output stream. Abstract integer readoff returns either a Unicode code unit or -1 when EOF. Abstract void write of integer C called with a Unicode code unit. The following diagram shows the reader and writer hierarchy. Closable, flushable, readable and appendable are the four additional interfaces. The classes input stream, output stream, reader and writer implement the closable interface. Output stream and writer implement the flushable interface. The readable interface has a single method, integer read of character buffer CB. The appendable interface has two methods for appending single characters and character sequences, namely appendable append of character C, appendable append of character sequence S. Zip file streams. Zip archives store more than one file in compressed format. Each zip archive has a header with information like the name of each file and the compression method that has been adopted. Use a zip input stream to read a zip archive. The getNextEntry method returns an object of type zip entry that describes the entry. The read method of the zip input stream is modified to return -1 at the end of the current entry. Call close entry to read the next entry. For example, code to read through a zip file. Use the following loop to read a text file inside a zip file. Scanner in equal to new scanner of zin. While of in dot hash next line of. Do something with in dot next line of. To write a zip file, use a zip output stream. To place each entry into the zip file, create a zip entry object. Pass the file name to the zip entry constructor. Call the putNextEntry method of the zip output stream to begin writing a new file. Send the file data to the zip stream. Finally call close entry. Use of streams. The following are some of the use of streams. Writing delimited output. Let us form a hypothesis that how to store an array of employee records in delimited format. Instant fields are separated from each other by delimiters. We use a vertical bar as our delimiter. Sample set of records. Aravind Mishra, 35,500, 1989, 10-1. Amit Chaudhary, 75,000, 1987, 12-15. Vikram Kumar, 38,000, 1993, 15. To write to a text file, we use the printWriter class. To write all fields followed by either a delimiter or for that last field a /n. To read records, we read in a line at a time and separate the fields. String tokenizers and delimited text. We need to find that delimiters to split the read line of input into individual strings and then separate out the individual pieces, that is, the sequence of characters up to the next delimiter. The string tokenizer class in java.util is designed for the above mentioned purpose. It is an easy way of breaking up a large string that contains a delimited text. While constructing the tokenizer object, specifying which characters are the delimiters is an easy one. Reading delimited input. To read one record into a string, use the following code. Buffer reader in equal to new buffer reader of new file reader of employee.dat. String line equal to in.readline of. To extract the individual tokens, we use the following code. Random access streams. If you have a large number of employee records of variable length, it is not possible to read a record in the middle of the file without leaving the previous records. If you make the records the same length, we can implement a random access method for reading back the information using the random access file class. To store numbers in binary format, we use the write integer and write double methods of the data output interface. To string the same size, use the methods write fixed string and read fixed string. The write fixed string method takes the parameter size. Then it writes a specified number of characters starting at the beginning of the string. Static void write fixed string of string s, integer size, data output out throws IO exception. Open bracket, integer I. For I equal to 0, I less than size I plus plus. Open bracket, character ch equal to 0. If I less than s dot length of ch equal to s dot character at of I, out dot write character of ch, bracket closed. Read fixed string method reads characters from the input stream until it has consumed size characters or until it encounters a character with Unicode 0. Static string read fixed string of integer size, data input in throws IO exception. Open bracket, string buffer b equal to new string buffer of size. Integer I equal to 0. Boolean more equal to true. While more double ampersand I less than size. Open bracket, character ch equal to in dot read character of I plus plus. If ch equal to 0, more equal to false, else b dot append of ch, bracket close. In dot skip bytes of 2 asterisk size minus I, return space b dot to string of, bracket closed. To write a fixed size record, we simply write all fields in binary. Public void write data of data output out throws IO exception. Open bracket, data IO dot write fixed string of name, name underscore size, out. Out dot write double of salary. Gregorian calendar, calendar equal to new Gregorian calendar of calendar dot set time of higher day. Out dot write integer of calendar dot get of calendar dot year. Out write integer of calendar dot get of calendar dot month plus 1. Out dot write integer of calendar dot get of calendar dot day underscore off underscore month, bracket closed. Reading the data back is just as simple. Public void read data of data input in throws IO exception. Open bracket, name equal to data IO dot read fixed string of name underscore size, in. Salary equal to in dot read double of integer y equal to in dot read integer. Integer m equal to in dot read integer of integer d equal to in dot read integer of Gregorian calendar calendar equal to new Gregorian calendar of y, m minus 1, d. Higher day equal to calendar dot get time of, bracket closed. Object streams. Object serialization makes it possible to write any object to a stream and read it again later. To save object data, open an object output stream object. Object output stream out equal to new object output stream of new file output stream of employee.dat. To save an object, use the write object method of object output stream class. Employee Aravind Mishra equal to new employee of Aravind Mishra hacker 50,000, 1989, 10, 1. Manager boss equal to new manager of Amit Chaudhary 80,000, 1987, 12, 15. Out dot write object of Aravind Mishra. Out dot write object of boss. To read the objects back in, first get an object input stream object. Object input stream in equal to new object input stream of new file input stream of employee.dat. Retrieve the objects in the same order in which they were written using the read object method. Employee even equal to employee in the bracket in dot read object of employee e2 equal to in the bracket employee in dot read object of. The class must also implement the serializable interface which has no methods. Class employee implements serializable. An object output stream monitors all the fields of the objects and saves their content. If an object is shared by several objects as part of its state, it is not possible to save it. To solve this, we use object serialization in which each object is saved with a serial number. Algorithm for object serialization. To write an object, associate a serial number with each object reference that you encounter. When encountering an object reference for the first time, save the object data to the stream. If it has been saved previously, just write same as the previously saved object with the serial number X. In reading back the objects, the procedure is reversed. When an object is specified in the stream for the first time, construct it, initialize it with the stream data, and remember the association between the serial number and the object reference. When the tag same as the previously saved object with serial number X is encountered, retrieve the object reference for the sequence number. Understanding the object serialization file format. Object serialization saves object data in a particular file format. Every file begins with a 2-byte magic number ACED, followed by the version of number of the object serialization format, which is currently 0005. It contains a sequence of objects in the order in which they were saved. For example, the string Harry is saved as 740005 Harry. When an object is saved, the class of that object must also be saved. The class description contains the name of the class, serial version unique ID, which is a fingerprint of the data field types and method signatures. A set of flags describing the serialization method. A description of the data fields. SHA is a fast algorithm that gives a fingerprint to a large block of information. The fingerprint is always a 20-byte data packet. The serialization mechanism uses only the first 8 bytes of the SHA code as a class fingerprint. When reading an object, its fingerprint is compared with the current fingerprint of the class. If they don't match, it means the class definition has changed after the object has been written and an exception is generated. Here is how a class identifier is stored. 72. 2-byte length of class name, 8-byte fingerprint, 1-byte flag, 2-byte count of data field descriptors, 78 n marker, superclass type 70 if none. The flag byte is composed of 3-bit mask defined in java.io.objectStream constants. Static final byte sc underscore write underscore method equal to 1. Class has a write object method that writes additional data. Static final byte sc underscore serializable equal to 2. Class implements the serializable interface. Static final byte sc underscore externalizable equal to 4. Class implements the externalizable interface. Each data field descriptor has the format 1 byte typecode, 2 byte length of field name and class name if the field is an object. Modifying the default serialization mechanism. At any cost, certain data fields like integer values that store file handles should never be serialized. In order to prevent such fields from ever being serialized, mark them with the keyword transient. If they belong to non-serializable classes, tag fields as transient. Transient fields are always emancipated when objects are serialized. A serializable class can define methods with a signature. Private void read object of object input stream in throws IO exception, class not found exception. Private void write object of object output stream out throws IO exception. The data fields are no longer automatically serialized, and these methods are called instead. A class can define its own serialization mechanism, save and restore object data by implementing the externalizable interface. It has two methods. Public void read external of object input stream in throws IO exception, class not found exception. Public void write external of object output stream out throws IO exception. The object stream creates an object with a no argument constructor while reading an externalizable object and then allows the read external method. Serializing singletons and type-safe enumerations. When a type-safe enumeration implements a serializable interface, the default serialization mechanism is not appropriate. To solve this problem, you need to generate another special serialization method known as readResolve. If the readResolve method is defined, it is called after the object is deserialized. It must return an object which becomes the return value of the read object method. Example: protected object readResolve throws object stream exception. Open bracket. If value equal to 1, return orientation dot horizontal. If value equal to 2, return orientation dot vertical. Return null. Bracket closed. Versioning. Changes in a class definition leads to changes in its SHA fingerprint. In turn, it results object streams will refuse to read in objects with different fingerprints. However, a class indication is there that it is compatible with an earlier version of itself. To do this, you must first obtain the fingerprint of the earlier version of the class. Use the standalone serial version program that is part of the JDK to obtain this number. Example: running serial var employee prints employee static final long serial version UID equal to -1814239825517340645L. All later versions of the class must define the serial version UID constant to the same fingerprint as the original. Class employee implements serializable version 1.1. Open bracket. Public static final long serial version UID equal to -1814239825517340645L. Bracket closed. When a class has a static data member named serial version UID, it will not compute the fingerprint manually but will use that value instead. Using serialization for cloning. Serialization mechanism renders you an easy way to clone an object provided the class is serializable. Serialization of an output stream helps in reading it back. The result is a new object that is a deep copy of the existing object. You can use a byte array output stream to save the data into a byte array. File management. The path and files classes encapsulate the functionality required to work with the file system on the user's machine. The stream classes consider the contents of files, whereas the classes that we discuss here are concerned with the storage of files on a disk. Path. A path contextually means a sequence of directory names optionally followed by a file name. The first component of a path may be a root component such as / or c:/. The permissible root components depend on the file system. A path that starts with a root component is absolute, otherwise it is relative. Path absolute equal to path.getOf/home, CAY. Path relative equal to path.getOf myprog, conf, user.properties. A static path.get method receives one or more strings which it joins with the path separator of default in the file system. For a Unix-like file system, / for Windows. It then parses the result, throwing an invalid path exception if the result is not a valid path in the given file system. The result is a path object. It is very common to combine or resolve path. The call p.resolve of q returns a path according to these rules. If q is obsolete, then the result is q. Otherwise, the result is p, then q, according to the rules of the file system. The opposite of resolve is relativizing. The call p.relativise of r yields the path q, which when resolved with q yields r. The normalize method removes any redundant and components. The toAbsolute path method yields the absolute path of a given path starting at a root component. Reading and writing files. The files class makes quick work of common file operations. For example, you can easily read the entire contents of a file. Byte array bytes equal to files.read all bytes of path. If you want to read the file as a string, call read all bytes followed by string content equal to new string of bytes character set. But if you want the file as a sequence of lines, call list string lines equal to files.read all lines of path character set. Vice versa, if you want to write a string, call files.write of path content.get bytes of character set. To append to a given file, use files.write of path content.get bytes of character set standard open option append. You can also write a collection of lines with files.write of path lines. For large or binary files, use input stream in equal to files.new input stream of path. Output stream out equal to files.new output stream of path. Reader in equal to files.new buffer reader of path character set. Writer out equal to files.new buffer writer of path character set. These convenience method save you from dealing with file input stream, file output stream, buffer reader or buffer writer. Copying, moving and deleting files. To copy a file from one location to another, simply call files.copy from path to path. To move the file, that is copy and delete the original, call files.move from path to path. Unless the target does not exist, the copy or move will fail. If you want to overwrite an existing target, use the replace _ existing option. If you want to copy all file attributes, use the copy _ attributes option. Files.copy of from path to path, standard copy option replace _ existing, standard copy option copy _ attributes. Use the atomic _ move option to assure that either the move completed successfully or the source continues to be present. Files.move from path to path, standard copy option atomic _ move. To delete a file, simply call files.delete of path. This method throws an exception if the file does not exist. So instead use boolean deleted equal to files.delete if exist of path. Deletion methods can also be used to remove an empty directory. Creating files and directories. To create a new directory, call files.create directory of path. To create intermediate directories as well, use files.create directories of path. You can create an empty file with files.create file of path. There are convenience methods for creating a temporary file or directory in a given or system specific location. Path new path equal to files.create temp file of dir, prefix, suffix. Path new path equal to files.create temp file of prefix, suffix. Path new path equal to files.create temp directory of dir, prefix. Path new path equal to files.create temp directory of prefix. dir is a path and prefix slash, suffix or strings which may be null. For example, the call files.createTemp file of null dot text might return a path such as temp slash 12355223648 dot text. Getting file information. The following static method returns a boolean value to check a property of a path. Exist is hidden, is readable, is writable, is executable, is regular file, is directory, is symbolic link. Size method returns the number of bytes in a file. Long file size equal to files.size of path. The getOwner method returns the owner of the file as an instance of java.nio.file.attribute.user principal. All file systems deploy a set of basic attributes encapsulated by the basic file attributes interface. The basic file attributes are given as below. The times at which the file was created, last accessed, and last modified as instances of the class java.nio.file.attribute.filetime. Whether the file is a regular file, a directory, symbolic link, or none of these. The size of the file. The file key, an object of some class specific to the file system that may or may not uniquely identify a file. To get these attributes, call basic file attributes equal to files.read attributes of path, basic file attributes dot class. Iterating over the files in a directory. The files class has a method that results an iterable object. Try directory stream path entries equal to files dot new directory stream of dir, open bracket, for path entry entries, process entries, bracket close. The try with resources block assures that the directory stream is effectively and properly closed. There is no specific order for the visiting of directory entries. You can filter the files with a globe pattern. Try directory stream path entries equal to files dot new directory stream of dir, star.java. The globe patterns as shown in this table. In order to visit all descendants of a directory, instead call the walkFileTree method and supply an object of type fileVisitor. That object gets notified when a file or directory is encountered. FileVisitResult visit file of tpath, basic file attributes attrs. Before a directory is processed, FileVisitResult pre-visit directory of tdir, IOException.ex. After a directory is processed, FileVisitResult post-visit directory of tdir, IOException.ex. When an error occurred trying to visit a file or directory, such as trying to open a directory without the necessary permission, FileVisitResult visit file failed of tpath, IOException.ex. In each case, you can specify whether you want to continue visiting the next file, FileVisitResult.continue. Continue the walk but without visiting the entries in this directory, FileVisitResult.skip_subtree. Continue the walk but without visiting the siblings of this file, FileVisitResult.skip_siblings. Terminate the walk, FileVisitResult.terminate. If any of the method throws an exception, the walk is also terminated, and that exception is thrown from the walkFileTree method. Zip file systems. The path class looks up path in the default file system, the files on the user's local disk. If the zip name is the name of a zip file, then the call file system fs equal to file systems dot new file system of path dot get of zip name, null. Establish a file system that contains all files in the zip archive. To copy a file out of that archive using its name, files.copy of fs.getPath of source name, target path. To list all files in a zip archive, walk the file tree. File system fs equal to file systems dot New file system of path.get of zipname command null. Files.walk file tree of fs.getPath of slash new simple file visitor path open bracket public file visit result visit file of path file basic file attributes attrs throws IO exception open bracket system.out.println of file return file visit result dot continue close bracket. Regular expressions. Regular expressions are used to specify string patterns. Use regular expressions to locate strings that match a particular pattern. You need to specify exactly what sequence of characters is a legal match using a special syntax to describe a pattern. Example, the regular expression JJ Java plus matches any string of the following form. First letter is a capital J or small j. Next three letters are AVA. The remainder of the string consists of one or more arbitrary characters. Understanding the syntax. A character class is a set of character alternatives enclosed in brackets such as capital J, small g, 0 to 9, capital A to capital Z, small a to small z, or power 0 to 9. The hyphen denotes a and power denotes the complement, all characters except those specified. To include a hyphen inside a character class, make it the first or last item. To include a square bracket, make it the first item. To include a power, put it anywhere but the beginning. You only need to escape square bracket and slash. There are many predefined character classes such as /d digits or /p sc. Most characters match themselves, such as the characters in the preceding example. The symbol matches any character. Use slash as an escape character. For example, slash goes with the period and double slash matches a backslash. Power and dollar join the beginning and end of a line respectively. If x and y are regular expressions, then xy means any match for x followed by a match for y. X or y means any match for x or y. You can apply quantifiers x plus 1 or more, x star 0 or more, next question 0 or 1 to an expression x. By default, a quantifier matches the largest possible repetition that makes the overall match succeed. You can modify that behavior with suffixes reluctant or stingy match, match the smallest repetition count, and plus possessive or greedy match, match the largest count even if that makes the overall match fail. You can use groups to define sub-expressions. Enclose the groups in oval bracket, for example, plus minus question mark within square bracket 0 to 9 plus. The following table shows the regular expression syntax. The following table shows the predefined character class names. Simplest use for a regular expression is to test whether a particular string matches it or not. The following are the steps. Construct a pattern object from a string containing the regular expression. Get a matcher object from the pattern and call its matches method. Example, pattern equal to pattern.compile of pattern string. Matcher equal to pattern.matcher of input if matcher.matches of. The input of the matcher is an object of any class that implements the character sequence interface, such as string, string builder, or character buffer. When compiling the pattern, you can set one or more flags. Example, pattern equal to pattern.compile of pattern string, pattern.case underscore insensitive plus pattern.unicode underscore case. The following 6 flags are supported. Case underscore insensitive match characters independently of the letter case. By default, this flag takes only US ASCII characters into account. Unicode underscore case. When used in combination with the case underscore insensitive, use Unicode letter case for matching. Multiline, power and dollar match the beginning and end of a line, not the entire input. Unix underscore lines only recognize /n as a line terminator when matching power and dollar in multiline mode. Dot all. Make the dot symbol match all characters, including line terminators. Canon underscore EQ. Take canonical equivalents of Unicode